Hello, my name is Denise and I am lecturer in Environmental Engineering. Welcome to the course Modeling of Environmental Systems. Through this course, we will provide you with concepts, theories, and skills to build mathematical models of environmental systems. This knowledge is directly relevant to your engineering career. This will be done by using systems thinking and modeling approaches, with a number of examples on several important systems related to population, ecology, reservoirs, and climate change. Environmental models are abstract representations of reality that can be used to improve our understanding of the natural systems or to assist in taking management decisions. Environmental processes consist of complex interactions between physical, chemical, and biological processes. These aspects of the basic modeling process constitute the major part of this course. In addition, many other factors may influence the process, such as climate, human intervention, geography, natural disaster, etc. The task of the modeler is to translate non-numerical concepts and facts into mathematical equations that describe the system evolution in quantitative terms. The most important of these can be expressed in engineering terms, using scientific and engineering techniques of mass and energy balances, microbial and population kinetics, thermodynamics, transport processes, chemical and biochemical reactions. Often, the representation of systems leads to differential equations, which are conditions concerning the change of a variable, like concentration or population density in space and time. For most problem formulations in terms of differential equations, numerical methods are required, as in many cases there is no explicit formula available. But don't worry too much about this, because we will use powerful software that will help us to solve these equations. In this course, we will learn to implement these methods or to use outward strategies available in software packages. Engineers have had a direct influence on many of the environmental problems that we face today. For instance, the pollution caused by industries, core exhaust fumes, mining and smelting, and ecological damage caused by the construction of reservoirs and roads. The engineer nowadays has an important role to play in designing processes or making decisions that help to improve sustainability. Engineering principles are also applied to the study of natural processes, such as the flow of water in rivers and lakes, the transport of solutes through soil, and the mixing of water bodies by wind. As explained, a considerable part of the course concepts of environmental modeling are introduced, starting from basic principles, tackling differential equations and numerical solutions. But in another similar big part of the course, the implementations of these concepts are introduced and described. For this, examples of environmental models are discussed. These include models involving chemical and biological transformations, such as ecological models as well as water and air pollution, population dynamics, global climate change, water balances in reservoirs, energy and mass transfer, and finally, urban dynamics. By using these examples, the student will learn at first to define the problem. Thus, the student will be provided with scientific and technical information that offers background to the topic. It is intended simply to provide enough information to establish a foundation on which the system models can be formulated. Students who have little background in the problems presented in these examples are encouraged to refer to additional reading materials. Following each section of the course will help the student to consider the following questions. What are the important concepts of this system? How these components related conceptually and mathematically? How can the system diagram be constructed that illustrate these relationships? What genetic systems constructs can be identified? And what do these constructs imply about systems behavior? How does the system react to various perturbations or changes? How sensitive is the system to changes, and what does this imply for system stability? Where might be human-natural system interface occur, and what impacts are expected from human-caused perturbations in the system? The other staff members and I look forward to seeing you in this course.